Hello there, this is General Mahendra Popat. We are discussing Geotechnical Engineering Particle Size Analysis, in which in previous video we have learned CGS and FGS, coarse grained and fine grained soil, as well as sieve analysis and particle size distribution curve and its uses. Let us go understand wet analysis, the second type of analysis on particle size. For wet analysis or sedimentation analysis, Stokes' law is followed. According to Stokes' law, larger particles settle first and then after smaller particles will settle. In other words, the velocity at which grains settle out of suspension is dependent upon the size, shape and the weight of grain. It has some assumptions, and those assumptions are also its limitations. So let us check one by one. The analysis with Stokes' law is based on the assumption that falling grain is spherical, but in soils the finer particles are never truly spherical. They are usually flaky or needle-shaped. They do not settle out of the suspension in the same manner and the same rate at smooth spheres. Thus, the sedimentation analysis gives the particle size of equivalent diameter. Second assumption or limitation is that Stokes' law is applicable for spheres of diameter between 0.2 mm to 0.2 micron. It may be noted that spheres of diameter larger than 0.2 mm falling through water cause turbulence, whereas for spheres with diameter less than 0.2 micron, the Brownian movement will be caused, and the velocity of settlement is too small there for accurate measurement. So, in both the cases, Stokes' law is not applicable. The third point, it is assumed that the soil has an average specific gravity, but different particles may have different specific gravity depending upon their mineral constituents. And the last assumption, the finer grains of the soil carry charge on their surface and have a tendency of flock formulation. A flock is an accumulation of small particles. The flocks then settle. Thus, if the tendency to flock formation is not prevented, the diameter measured will be the diameter of the flock and not of the grain. Thus, some deflocculating agent like sodium hexametaphosphate or sometimes sodium oxalate must be used. So these are assumptions or limitations of Stokes' law. Moreover, fine grain analysis is carried out by the hydrometer method or pipette method. The principle of the test in both the methods is same. The difference lies in the method of making observations. In the pipette method, the mass per ml of suspension is found directly by collecting a 10 ml sample of soil suspension from some sampling depth. However, in the hydrometer method, it is computed directly by reading the density of the soil suspension at particular depth at various time intervals. In hydrometer method, to determine the depth at which the specific gravity is measured, calibration of hydrometer is also done. For that calibration, we need to discuss some corrections to hydrometer. let us discuss that these are corrections to hydrometer which are applied after calibration of the device. Sometimes it happens that if you have calibrated the device, still the readings go in the wrong direction. Then at that time these corrections will be crucial to the process. First correction, meniscus correction, or C and in suffix M, which is always positive. Since the soil suspension is opaque, the hydrometer reading is taken at top of meniscus. So the meniscus correction is always positive. The meniscus correction is determined from the difference in height between the top and bottom of the meniscus by inserting the hydrometer into another jar containing clear water. Second correction, temperature correction. The hydrometer is generally calibrated at 27 degrees Celsius. If the temperature of the soil suspension is different from 27 degrees Celsius, a temperature correction is required for hydrometer reading, and it is denoted as C and in suffix T. In simple words, we can tell that if test temperature is more than 27 degrees Celsius, CT, temperature correction will be positive, and if at the testing time temperature is lesser than 27 degrees Celsius, CT is negative. The third correction, dispersing agent correction, known as C and in suffix D, CD. The addition of dispersing agent to the soil specimen increases density of suspension. Therefore, the dispersing agent correction is always negative. So these are the corrections to the hydrometer readings. Going forward, let us understand a problem regarding the soil particle size analysis. Problem is like that. Classify the given soil sample. Here two readings are given. Readings are given in two terms. One, N percentage, and two, F bracket in bracket mm. So N percentage is showing percentage passing or percentage finer, and fines or F in bracket mm is showing particle size, which is how many percentage finer. So if I talk about 10%, less than 10% finer material, it will be of size 1.28 mm. Another three things are given, that is G means gravel is equal to 20%, sand is equal to 78%, and fines is equal to 2%. So overall more than 50% is this sand. Let us go to understand solution. As G, S and F are provided, due to S is equal to 78%, given soil is sand or CGS. Now we should understand the values of D10, D30 and D60. So D10 means particle size such that 10% of the soil is finer than this size, where D30 and D60 also means that particle size such that 30% and 60% of the soil is finer than that size. Now D10 is equal to 1.28 here, D30 is equal to 3.07 mm here, and D60 is equal to 4.8 here. Now I will find Cu and Cc. Coefficient of uniformity is equal to D60 by D10. Now I'll put values so that I am getting Cu as 3.75. From the previous table, we should remember that if Cu value is less than 5, it will be uniform size particles or uniformly graded soil. Now let us find out Cc. Cc is equal to d30 square upon d60 into d10. Putting all the values, I'll get Cc is equal to 1.53. We should remember that if Cc is lying in between 1 and 3, the soil type will be well-graded soil. Now, we already know that the soil type will be sandy. So we can write Cu is 3.75. That means uniformly graded sand, and Cc is 1.53. That means it is well-graded sand. You can practice this type of problems more. I'm concluding my video here. That's it for particle size analysis. Thank you.